In programming, subroutines are essential constructs that allow developers to write efficient, organized, and maintainable code. A subroutine is a named block of code designed to perform a specific task, which can then be executed whenever needed by calling its name. By encapsulating functionality into reusable components, subroutines help programmers avoid repeating the same code in multiple places. This not only saves time during development, but also makes the program easier to understand, test, and modify. One of the most significant benefits of subroutines is their ability to eliminate redundancy. In a program without subroutines, the same code might need to be written repeatedly to perform identical tasks in different parts of the program. This repetition increases the risk of errors, makes the code harder to maintain, and wastes valuable time. By using subroutines, a programmer can define the task once and reuse it as many times as necessary, simply by calling the subroutine in. For example, consider a program that calculates the square of a number multiple times in different contexts. Instead of writing the calculation each time, the programmer could create a subroutine called calculateSquare that takes a number as input, computes its square, and then returns the result. Whenever the square of a number is needed, the program can call calculateSquare, making the code both cleaner and more efficient. Some subroutines are designed to return a value to the part of the program that called them. These are often referred to as functions in many programming languages, although the distinction between subroutines and functions can vary depending on context. Subroutines that return a value are particularly useful because they allow the result of their operation to be directly used in further calculations or operations. For instance, in the example of the calculateSquare subroutine, the returned value, the square of the input, can be stored in a variable, displayed to the user, or passed into another subroutine for additional processing. The ability to return values makes subroutines versatile and powerful, enabling them to interact seamlessly with other parts of a program. To return a value, a subroutine typically uses a return statement. When the return statement is executed, the subroutine's operation ends, and the specified value is sent back to the calling code. For example, in a program that calculates the total cost of items in a shopping cart, a subroutine called calculateTotalCost might take the list of item prices as input, add them together, and return the total. The main program can then use this returned value to display the total to the user or apply additional calculations, such as adding tax or discounts. Subroutines also contribute to better program organization by promoting modularity. By breaking a program into smaller, self-contained subroutines, programmers can focus on developing and testing each part independently. This modular approach not only makes debugging easier, but also enhances code reusability. A well-designed subroutine can often be reused in other programs or projects with minimal modification, saving time and effort in future development. In addition, subroutines improve the readability of code. Instead of cluttering the main program with lengthy and repetitive operations, subroutines allow these operations to be neatly encapsulated and abstracted. When reading or reviewing code, a subroutine name such as calculateSquare or display welcome message immediately conveys its purpose, making it easier to understand the program's overall logic. This clarity is particularly valuable in collaborative projects where multiple developers need to work on the same codebase. In summary, subroutines are a fundamental programming technique that helps to avoid repeating code by encapsulating tasks into reusable blocks. They not only simplify the development process, but also improve code organization, readability, and maintainability. Subroutines that return values add further functionality, enabling seamless interaction between different parts of a program. By using subroutines effectively, programmers can write code that is efficient, modular, and adaptable to changing requirements, ensuring the creation of robust and well-structured software.